We have the unique benefit of two expertise tonight. The first speaker is from FireBlock, and that is Kieran, and he's going to give us a presentation in relation to his production manufacturing of steel doors. The second presentation is by Mark O'Donoghue, and he's from Forster Profile Systems, and he's going to give us a presentation on the products associated with the ones that Kieran would use on a regular basis. So without any further delay, Kieran, if you would like to start your presentation. Thank you very much.
Good evening, folks, and thank you very much for the opportunity. Thank you, Sinead, for the introduction, and we'll dive straight into it. So I suppose my presentation will take approximately 20 minutes, and Mark's presentation will take about the same, and we'll break into Q&A afterwards. So I guess how we've structured my presentation is I want to go through the standards that affect the doors and windows and louvers we make. FireBlock is the name of the company, as you can see on the screen, that I work for. We're a manufacturer in Ireland of hollow metal steel doors, windows, louvers, and we're an agent for Forster Windows. So I'll get going as we'll see how we go. So for fire rated doors, the standard we work to is the 16034 harmonized product standard, which is the standard for fire resistant doors and windows. It's made up of a subgroup of a number of test standards, classification standards, and EXAPs, and EXAP guidelines, and we're going to go through those at the moment. So there you have the EN 1634. You have the EN 1634-1, which is the actual test, the full scale test for the doors. The EN 1634-2, which is the indicative test for the doors, we'd say for locks and small items of ironmongery if you want to test in the doors. The EN 1634-3, which is a smoke control, and that moves on into the classification report and the EXAPS reports, which we'll deal with in more detail get into more detail later on. So the EN 1634 test door shutters, doors, fire shutters, and openable windows. The test is broken up into three parts. We'd say which is integrity only, which is we say for it'll stop the fire, but it won't stop the heat. Integrity and insulation, which stops the fire and the heat, which is denoted by EI. Integrity only being denoted by E. And then you have radiation, which is denoted by W, which stops the heat and some of the radiation. During a fire test, we'd say the fire door, as you can see here, is put into a test jig. The test jigs are generally 3 meters by 3 meters. It's put into a whatever structure you deem you want to test your door in. In this case, FireBlock have tested this door in a concrete wall structure. And I suppose the point I want to get across here is how difficult the tests are to pass. If you get a product on your site, or you're presented with a product that has a test to EN 1634-1, it really is a hard test, and it's a very in-depth test to cross. Here on the left-hand side of the screen, you can see the temperature curve. So the temperature starts at about 380, and within 30 minutes has gone up to 800 degrees. And depending on how long your test lasts, it can go up to 1100, 1200 degrees. The door, how the door passes, obviously, is the door, any flames or hot gases don't pass through. The measurements of the doors, or the increments, are from 15 up to 240 minutes. The failure criteria: if you have a flicker of flame for more than 10 seconds, you're failed. If you have a gap gauge where you can stick a 6mm rod through to the furnace and move it around 150mm freely, your door has failed. Or if there's a 25mm gap comes in the door, or the door between the door and the frame, your door fails also. This door, for example, we were testing to E60 integrity only. We got an overrun, which is 68 minutes, which is applicable to the EXAPs. However, at 80 minutes, there was just a flame for 10 seconds, just came up at this point here. So like, if you can imagine, to get this door tested, you're probably looking somewhere in the region of 30,000 euros. whether you test it in Ireland or in the UK, and your whole thing stops if you flicker them for more than 10 seconds. I guess over the last since FireBlock has been in existence since 1998, we've done something in the region of probably maybe 50 tests, 45, 50 tests, and of late, over the last couple of years, we've done something in the region of about 15. The installation value, there are two, so that's the integrity, the EI, the installation value. There's two categories within the EI system. There's EI1 and EI2. EI2 is mainly used or sorry, EI1 is mainly used in Belgium. If the door reaches a certain temperature within, I think it's 25 millimeters from the door, whereas the EI2 is about 120, 130 millimeters actually 100 millimeters from the door, excuse me, if it reaches that temperature. And it measures the fire resistance of the door, but also the heat transmission through the door. So I suppose it's applicable, we say, on escape corridors, where if you people would say running down a corridor, it's fine if the fire stops the door for integrity, but for installation, people don't want to get burnt as they're running past the door, and if there's 800 degrees at the other side of the door, transmitting through it. The thermocouplers are the temperature gauges they put on the door. You can see them here. The red circles 100 mil from the leaf for EI2. The yellow ones are closer to the weaker areas for EI1. The triangles then are for EI1 and EI2, and the blue squares are for the testing the temperature on the outer perimeters of the door. Radiation is somewhere then in between the integrity and integrity only and insulation, where it measures the radiant heat through the door from a distance back for up to 15 kilowatts. 1634-3 is the part within the standard that measures the smoke control. The most common is the cold smoke control, which is denoted by SA. I suppose when we look at door schedules a lot, we see 60S, 30S, and we take that as being an SA because that's accepted as being the baseline for smoke retention. However, there is an S200, which is the hot smoke test. The standard for the testing is 3 meters cubed per linear meter per hour at 50 PA. And that's again, that's put into a test jig and tested on site by Warrington, Effectus, or any one of the test houses. If you're going for a classification report, which we'll hit earlier, you need to both the fire test and the smoke test. The classification report here, you have your door type, for example. You have your EN 1634-1 for the fire, and or the smoke test EN 1634-3. And then from there, you get your classification report, which amalgamates the two. The types of classification reports would be the E90 integrity only, EI90 integrity and installation, EW90 integrity and installation again, and EI90S, which would be integrity, installation, and smoke rating. Once you have your tests, then we'd say, and I suppose to something we get asked a lot of, we'd say when we're going through the approval process, engineers, architects will ask to look at fire test evidence. Now, the fire test evidence document is a very complicated document, and we say with temperature curves, with timing of reactions to the doors as the fire test is progressing. So I suppose the easier way for us to look at it and to pass it on to our clients is to get an extended application where basically the fire test house will take all of our test evidence, the integrity only, and the smoke rating, etc., and they'll put it all into one document, and they'll set the parameters then within that document. So that's called the XAPS, and that's referred to as a global assessment. To move on, I suppose, to the FireBlock doors and how they apply to that. FireBlock this is our product range, from commercial doors, fire-resistant doors, acoustic doors, blast doors, fire-rated screens, sliding doors, louvers, windows, heavy-duty utility doors, and we do a lot of clean room doors. I suppose the approach we try to take is front end, where we try and engage with engineers and architects at the start. So as that we'd say, for example, we would get a lot of interaction from engineering practices. I have a wall that I want to do EI 90. I need the door to be access controlled. I need windows on it. And again, once we have that information, we can do up drawings and do up schedules and how we can approach it, or if we can do something close to it, or maybe a workaround or whatever way it may work. Again, we say with adherence to project budget, specification, and again, I suppose now the big one being sustainability. On the sustainability element, all of our products, being steel, are fully recyclable. We get most of our steel, for example, from Tata Steel. And again, we say the level of recycled steel within their product is increasing exponentially all of the time. Also, I suppose we'd say as regards to the efficiency of buildings, we've the doors tested up to the new Part L standard, which is 1.6 U value on external doors. Also, we recently completed air permeability tests on the doors, and we achieved the highest class of Class 4, which again, if you keep the heat inside the building, you're not burning electricity or fossil fuels to maintain it. Labeling and certification. Any fire door that you'll see on any building needs to have the manufacturer's name on it, the year of manufacture, the fire rating, and its own specific door number. So like if there's an issue with a door, you can call the manufacturer, you can say, look, I'm looking at door B12345, and we're obliged to say, look, yes, that's a 60-minute door, it's 35 dB acoustic rated, and it's, for example, 5 kilonewton blast rated. Every external door in both fire rated and non-fire rated is covered under the harmonized standard of 14351-1 and 16034 2004, which basically means that every door for external use needs to be CE certified and CE labeled. Internal doors, as of yet, are not covered by the harmonized standard. It's envisaged they will be covered in time. So the internal doors just need their components CE certified, i.e. their locks, closers, hinges, etc. Fire rated doors, FireBlock have doors fire rated up to 300 minutes. Again, just as an example to see how these things work, this actually is a factory which burnt down. This door here in the corner, as you can see, the whole building has melted basically. Your mass concrete wall is still there. Ironically enough, actually, this building was a coffin factory. There was a machine inside and it went on fire from a fluorescent tube. Actually, the subsequent investigation found out. But as you can see here, even the paint hasn't come off the outside of the door. So that's a good example of an EI door. We manufacture door types. I suppose clean room doors available in all kinds of finish and all kinds of specification. I suppose we'd say the clean room doors, for example, we're doing at the moment for pharmaceutical companies that are making the weight loss drug, which is very topical right now. That process requires the area to be ATEX rated. So they require the area to be ATEX rated. They require a door to be access controlled. And they also require the door to be 120-minute fire rated. And finally, they require the door to be automated so it can get no trolleys. So in that case, we ended up getting a site-specific assessment where we got pneumatically operated doors with pneumatically operated access control, blast rated to 10.5 kilonewtons and fire rated to 120 minutes. So again, that's an example of where the engineering company would have engaged with us at early stages, and we were able to tweak the product and do any necessary testing or appraisals to get the door to achieve the functionality required. Acoustic doors, again, tested to BSEN 140-3 and to ISO 717-1 2020. I suppose the The beauty of FireBlock doors and the Forster doors is they combine fire rating, blast rating, acoustic rating. And again, we'd say the FireBlock door specifically, we've been tested up to 42 dB rated. Again, I suppose we'd say when a lot of the particularly around Dublin, actually. We'd say a lot of the companies and data centers we're working on have energy centers and that kind of thing. The energy centers have generators, etc., going inside them. They need to be fire rated to a high level, but they also need to be acoustic rated so that they don't annoy their neighbors. So again, we say there's, for example, there's 42 dB doors with a 60-minute fire rating going to a project at present. Blast rating. We've dynamically and statically blast tested the doors to the EN 16933, where basically we take the doors to an army base in the UK and we blow them up, and we get the reading from them from an independent third party. Sliding doors. We fire rated to 40 minutes. Again, we'd say just on a sliding door, fire rated sliding door needs to be automated, because any fire rated door needs to be self-closing. So if anybody wants more information on them, please come back to me. Windows, Mark will hit this more in his side of the presentation, but we manufacture clean room windows, which are a flush finish each side, fire rated up to 300 minutes, acoustic rated if required, and also blast rated if required. I suppose clean room application is probably the most widely used here. Heavy duty utility doors. The ESB, I suppose, will be one of the bigger guys here. Irish Water and that kind of thing. We're nominated by Irish Water as one of their suppliers. We have been so since 2004. So we manufacture the doors again to suit their specifications, and supply and install, and ESB signed off. You can see this building here. This is actually a waterworks building where a bespoke door and a bespoke solution was manufactured and installed for the application. Door furniture. The thing about the I suppose door furniture, at the early onset of projects, we like to go through the functionality of the doors with the engineers looking after it, be it the escape, be the EN 179 escape, which is low occupancy, EN 1125 escape, which is higher occupancy, for example. And couple that, we say, with the performance criteria for the door, i.e. is it fire rated, is it blast rated, is it acoustic rated, just to match the ironmongery with the performance of the doors, and make sure that our global assessment document or extended application document covers it, that you're not fitting an element to the door that detracts from the fire rating, the blast rating, or the acoustic rating. Scheduling systems. So again, look, I suppose this is probably more for contractor level, where we said order received, takes maybe a week to do drawings, but then doors manufactured 7-8 weeks. So like again, I suppose to give yourselves time, you're probably looking at the whole process taking maybe 10-12 weeks, depending on what kind of client buy-in you get on at the start of the job. We find, as I'm sure you do yourselves, a lot of the time a client won't start making their mind up on regards functionality until they see a drawing in front of it, and then it starts changing. And maybe when you get to ultimate frustration at Rev 5 of drawings, you might get some level of sign off. But look, that's just to give you an idea of manufacturing. Generally speaking, in Ireland, you're looking at maybe 10-12 weeks for manufacture of doors. And I guess we'd say for our export market, we export maybe 30-40% of our products across Europe to data centers, I guess, in particular, and pharmaceuticals. Again, 10-12 weeks plus a week of transport to whatever site we're going to at any one time. I see my time is nearly up, so I'm just going to fly through the rest of it. Just some examples of pharmaceutical doors, data center doors. Again, we say large doors, fire rated, with access control, airmongery. Food manufacturing doors with a food safe finish on them, flush glazing, drop seals for air transfers. Commercial doors is actually in a sports hall. This is more Mark's thing, where we bespoke windows for E60 in a building in Kilkenny. Life sciences, again, I guess a lot of the time we say when citing pharmaceutical companies or washdown companies that where there's washdowns happening, um, or doors being made from mild steel, from Syntec. There is a level of corrosion protection on them, being Syntec or galvanneal. However, if they are sitting in water over a prolonged period, the bottoms of the frames can sometimes corrode. This is a life sciences company where the there's a big washdown every evening. They didn't want to pay for a full 316 stainless steel door, so we made 316 stainless steel frames, which are always on the ground, being the bottom of the frame. The door leaf being elevated inside in the heated area, it's not going to hold water for long. So the compromise and the value engineering aspect of it was certify the door for 60-minute fire rated. With the stainless steel frame and the painted or powder coated Syntec door leaves. The door on the left here, they wanted in the life science again to get maximum glazing, but they wanted something where a trolley could go down the corridor and wasn't going to damage the bottom of the door. So they wanted a 500 mil upstand at the bottom. So we came up with a solution where, with the agreement of the fire officer on site, we put in structural steel, wrapped it with Promatec board, allowed a 10 mil gap between each of the elements, window 1, window 2, window 3 on top, and the door being the fourth element in the middle, and certified them as individual units, given that there was a 10 mil gap between them. Again, this is battery plant, which I guess is typical now. These are ducts going up, and I guess this is partially why we done the air permeability test, where the relative humidity between the manufacturer areas and the general circulation areas is a huge element in battery manufacture. And again, I suppose we achieved the highest class or the highest level. That's just some data center doors, access control doors. Again, some of Mark's stuff. Again, access control doors, and my apologies for flying through this. No, I'll come back to it in time. So, I guess, listen, thank you very much for your time. And I'll hand over to Mark and look forward to your questions and Q&A session afterwards.
As Mark O'Donoghue, I am Business Development and Specification Manager for Forster Profiles. The CPD I have here, I have a shortened version of you for you this evening. It is a registered training provider, CPD. Our company, just a brief outline, we're 100 years in existence. We make steel profiles, not aluminium, but we're part of an aluminium group called Reynolds. They bought us out a good number of years ago. We're active pretty much worldwide. We've direct sales in the UK and Ireland. As I said, we're part of the Reynolds group. What we do and what we do well is fire protection, smoke control, burglar resistance, bullet resistance, and thermal efficiency. So it's steel profiles for glazing systems. In the agenda, I'm going to try and bring you through passive fire protection, applicable standards, testing procedures, applications, and the big thing I'll touch on is benefit of using steel versus other materials. I think Kieran has touched on a lot of the stuff that I use in my TPD anyway, so I'll scooch through it. And if there's questions at the end, I'll take them at the end. So passive fire protection allows for protection of life, reduction of the build cost, maintaining the building's function as best as possible, protecting against the secondary ignition, also limits the spread of fire and smoke, compartmentalization, and the safe means of escape, and the safe means for firefighters' access. Fire containment and compartmentalization internally and compartmentalization externally. That's important. I come from the Façade industry for a long number of years. So compartmentalization on a facade or externally on a building on its envelope is hugely important. Integrity, Kieran has gone through all these. Integrity only is E. Integrity with radiation is EW. And integrity with insulation is EI. The big thing with integrity and radiation that Kieran may not have missed is radiated heat after a meter. The thermocouples are set at a meter out from the test wall on EW. And he's already spoken to you about EI, so I won't go through that again. This video here, and I'm going to quickly play for you, has got E on one side and EI on the other side. I know you're not talking loud on the or replying back, but most people, when I show them this video, I ask the question of which do you think is E and which do you think is EI? And believe it or not, 9 out of 10 times people choose the one on the right. Even though on the left-hand side, we're after seeing the insulation in the glass activated, and therefore the office on the left-hand side is the EI office. But as the video moves on, it'll just show you the significance of the difference between E and EI. E is the very basic standard of fire protection, and EI is the best standard we can offer. Whether it's 30 or 60 or 90 or 120, the time will work. In this example here, you will see that the E area that I have the cursor over here actually fails. It was supposed to last for E30. It even caught fire long before E30. But it's a good example that we done a video on with the help of another manufacturer in the industry who has a furnace, and we could video the whole thing. And it's just a great example to show you the difference between E and EI. You'll soon see this right hand side take hold of a fire. I'll let the video talk. There you go. So that's the difference between E and EI, and as you can see on the time clock up on the left hand side, it can even withstand it. So fire testing and what's it all about? Most importantly, this picture on the right hand side I want to show you, because I've worked in fire test labs for companies in my past, and I've done project management and I've done fire testing left, right, and centre. Usually I was doing it with aluminium. Normally, when I left a fire test lab after doing an aluminium test, there wasn't much left behind. In this test I done in the steel, I actually asked the lab to just fire up the furnace again so I could take this photo, because it's a very dark, dull room, just to show that the steel is there after the fire. And that furnace reached up, I think, to 1200 degrees Celsius. So the steel was still there afterwards. These are the testing standards that we as manufacturers have to adhere to. And Kieran has touched on all of them in throughout, but these are the actual documentations. We will sit with a test lab and go through every one of those, whatever we're deciding our product may or may not be, what we're wanting to achieve or what we're not wanting to achieve. There's a fundamental thing about this, and I was asked to me of a good engineer once upon a time. Yeah, he says, but you pass loads of tests, you fail loads of tests, but you only pass one, and then you go to the market with your product. Well, strictly in glazing and profiles, you can't really do that, because we have so many different products that line up with our product. We have got to go back and retest again with other products. So we may test the first time with PyroGuard, the next time with another glass manufacturer, etc., etc. I'm giving you examples of that. The same will go with the hardware. We will do an extensive amount of testing every year, and in fact, our company does in actual fact roughly around 20 to 30 tests every year, and that's not just new development of new products. That's just different designs with different different other products that go with our profiles. So we will test it in so many different ways. The most important thing, though, when we come down to testing, and it's something that you're not au fait with, and it's not something that's really noted out there so awfully much, is the fact of whether we do a test in high density, which is in the classification of EN, which is construction. Low density would be masonry block, or flexible construction, which would be a stud wall with steel gate posts, and also then for curtain wall and non-standard supporting constructions. So when you're specifying or when you're looking at a project, these are the most fundamental aspects. These are the starting points before we actually choose what product is good for you, or matches what you wanted to get to. And then you have your test and certification. Kieran has touched on all these. There's not much point I need to go back into them again for you, but you have the CE marking for curtain walls. That's an important test. We do that a lot. That's usually done in a 4 meter by 5 meter furnace. And when you're doing a curtain wall test, you have to do angles on it so that the angle is attacked in the fire as well too. Fire testing itself, it's a process that we go through, and the test reports are the only recorded data for what we've done. The next level on is an XAP or an accreditation. But when we're doing our testing, we very rarely as a company rely on accreditations. We'd like to have the test done more so than not. We do an extensive range of testing with a whole range of different other products that match with our products. So what I would always say to engineers and architects is, first and foremost, look for the test result. If you have the test result, you're off to a great start. After that, assessments, there's nothing wrong with them, but I look for the test result first, because that is the all-encompassing document. In the case of a test result, normally when a company like us release our test results, we release it in the first page only. We don't like to release the whole test data for what you're asking for, but we will do under NDA. It's a matter of us protecting our own interests and commercial abilities. Fire test assessments then is what I touched on and all too. We can go into a fire test assessment, and Kieran has fairly much explained that with XApps as well too. So they're the next level that you can go to. But I would always say my preference is to stick with the actual test evidence first and foremost. Testing procedures and results. Always check what I just said, that there is relevant evidence of a fire test resistance performance. Ensure that the installation of the glaze system, which is fundamental to the achieved its fire resistance performance. Now, that's a huge thing that an awful lot of companies and my competitors even miss out on. When we manufacture a product, but we have to give it to a fabricator like Kieran, and Kieran has to go fabricate it and install it. We, as a company, do third-party training to ensure that our fabricators and installers know what they're doing and that they don't make mistakes from taking our manufactured product and putting it together with other products and then install it. It has to be done by the book. So that's why we do our third-party accredited training. And we're glad to say that FireBlock is one of our companies that are fully trained with us. But from your own point of view as an engineer, never assume that the substitution of one component for another will result in the same level of fire resistance. So when you get a fire test, if it says X, Y, and Z components to go with it, don't change them out willy-nilly, because it just doesn't work that way. Because my own experience of being in test labs, as soon as you change something, it just probably, the likelihoods, even though you might change one small detail like piece of hardware for another piece of hardware, there's no guarantee it'll pass. And in fact, most times it won't. You'll have to find the way around it or engineer your way around it. And that brings me back to the test in itself, is that it's most important to understand, yes, companies like us will fail tests left, right, and center, but we will pass more than we will ever fail because we have to do it in so many different ways. But if you don't fail a test, you'll never learn how good your product is. You'll never be able to engineer it and work it through the test. The tests are, as Kieran has said, very rigorous and they're very difficult to pass. So testing itself is the bones of where we need to be at as an industry for when it comes to fire. Never mix and match components, and never be tempted to take a shortcut by reducing the performance of the specification. If anything, I'd let you go higher with your specification. So if you're an EI30 or an EI60, you will say, well, look, it might be easier if we go for EI30. It's probably best you go up to EI90. You'll probably work it. Because the tougher the longer period of time or the tougher the test is, the most likelihood is you're going to get all the answers you need in that documentation. Requirements for fire glazed elements in any building is there's the law, the code of practice, which is what we do with our test engineering and testing, and then you have the Plan B document, which is your guidance. This is what a lot of you work off of, and a lot of people will look for, fire officers will look for the test results, etc., etc. Sometimes engineers will come look for. It is complicated. Test results are generally very complicated documents. But if you ever want them, we've no problem in giving them to you under NDA. What we do is internal applications of fire doors, partitions, atriums, internal doors and screens. We cover most of all of the internal fire rated stuff in steel, anywhere from E30, which is the very basic level, up to EI 120. Internal partitions as well too, with butt joints, etc., etc. We cover all those. We manufacture product for those, test product for those. Atriums and all too, which is an important thing. We use them an awful lot here in Ireland due to a glitch in the Plan B document. If I put it that way, I won't go into that too much. It's more of an opinion than a requirement. But atriums in general are EI90. They don't really succeed. There's not too many people that will have an EI 120. So atriums are generally EI90s. We also do external applications, which are doors, fixed windows, curtain walls. And when we say doors, we have doors from now up to EI. That should be updated. We have doors up to an EI 60. Again, that door that we just have we're just about to launch. We have it in Bow this week, an EI 60 door. It actually has taken about 3 years of testing to get it through. So that just shows you how rigorous it is to get it. But we have it. We're one of the very few that will have an EI 60 door in the marketplace this year. External windows. When people look at fire windows, I always say it's a fixed window. It does nothing but you look in or you look out. It doesn't open. It doesn't close. There's no vents in it. There's no louvers in it. There's none of that. It's just a fixed window. It's simple. It does nothing else except for the fact that it's a visual aspect. But it is fixed and it is fire rated. And curtain walling, which is my aspect is of the industry, or what I target most, is the facade end of things. We have I'm going to bring it into the benefits of steel in a second, but we have in Ireland and the UK, we have an awful habit of automatically choosing aluminium in our facades. And I came from that background and I have no problem with that background. But when I came to work for a steel company, after a period of being in a test lab, I realized that the steel product was a much better product than the aluminium. And it's simply the benefits of steel that are very evident and very clear. As engineers, you'll understand these yourselves. But it's fire resistant up to 1400 degrees Celsius before it starts to melt. Aluminium will melt at 660. It's got a lower conductivity than aluminium. Its strength is 3 times stronger, so you can use an awful lot less mullions in facades. There's no reinforcements required, and you can work with larger spans. Line of sight is slimmer than you'll ever get with aluminium. Some of our profiles, external profiles, can be as thin as 23 millimeters. But also the back box, this area here, we don't need 300 or 400 mil inside a building to put all of our intromescent or insulation or whatever you're trying to achieve, U value or fire resistance. Our back boxes, don't need to be as deep as the aluminium back boxes. Therefore, you're saving an awful lot of space internally in the building with your client. Thermal performance, as I said, conductivity, it's better than steel. We have profiles now that are actually in our, which are not fire rated profiles, they're just a U value in curtain walling that our profile can achieve 0.49 or 0.47 actually. All right. But also, the last thing, the big benefit about steel is environmentally. It's 100% recyclable. Kieran pointed that out. And we have all the CPD certs, EPD certs that you will need on request. One thing that you might be thinking in your head there as an engineer, you're not a QS, but you are an engineer. So QSs would have told you thousands of the years, steel is way more, 40% more expensive than aluminium. The reality is, and that fact at the moment, due to the geopolitical issues over the last 6 to 8 years, steel is now on a same comparison as aluminium, cost-wise. So our profiles are there and thereabouts for the price of aluminium. So if you're looking for something that's more robust, stronger, resist fire better, need to use less of, and is 100% recyclable, steel is your option going forward. Finishes is that you can get available with steel. It's powder coating. You can get powder coatings now that are very metallic in look, and you can get them nearly like a stainless steel finish if you want. But because it's steel, you don't anodize, so it's PPC coatings, and or the other finish is a stainless steel finish. That pretty much is my presentation to you. I won't play it much longer because Kieran covered an awful lot of it. And if you have any questions, I'd be happy to take them.
Thank you very much. I think we can all agree there's two examples there of two companies working in partnership with each other for the Irish industry. There are a few questions there in the Q&A section. I do see Mark Doyle from our committee sitting there as well, so he can help me out with a few of these Q&A questions as well. So the first question that we have is, do you believe the radiation criteria of a 15 kilowatt is too high given most combustible floors on the non-fire side could ignite at that heat flux? Not too sure who that is, but I think it is probably for Kieran.
Okay, that's probably in relation to the EW standard, which is in between the integrity only and the integrity and insulation. So if there is materials that are likely to combust or that you fear may combust at the non-fire side of the door, the answer to that is not to go for the EW, to go for the EI, and that would 100% stop any heat transmission.
This is probably a related question as well, is what is the expiry date for the standard test report versus an EXAP assessment report?
Mark, you're sitting very quiet there. I'm going to get you to answer
Yeah, they last the same time, to be honest with you. Really, the expiry date is, how will I say it? At the moment, we're on EN 1634-1 2018. That's what is accepted. But I know EN 1634-1 2014 is also accepted. So it's really comes down to what the customer wants to use is how determines how long a standard test report is going to last like.
I presume that's in consultation then with the architect or the consultant associated with the product.
Pretty much.
Yeah,
like, I suppose if the standard doesn't change, the test report will remain valid. If a door held the fire for 60 minutes or 90 minutes, the actual test report will remain valid. No, the standards might change, and I suppose when we started testing first 20 odd years ago, the EN 1634 didn't require factory sampling, whereas it now does. So, like we say, but the test 20 years ago is still valid. For what it achieved at the time.
If I can interact there for a second, it's just in my own experience working in labs, when there's any major change to any test standard, every lab will get it immediately, obviously. We will generally always contact, or the labs will generally always contact their customers that have that test and will say, you need to update it if it is an actual update on the data or the criteria of the test. Sometimes, as Kieran pointed out there, you might need a factory sample. That wouldn't have required a retest. It might just require factory samples to be sent in. So it depends on how the EN criteria or development team set out the tests, and if they change it dramatically, it'll be well known, and all the manufacturers will know it very quickly.
Yeah,
it'll be a massive rush on labs.
And what's the second part of that question, the EXAPs, how long does that last? There is a time period on that, usually 4 or 5 years. You'll see valid until a lot of them are, we have some there are 2028, 2027, so you just have to go and get them revalidated, and the test house will check them against the latest standards.
Exactly, yeah. The standard question here that you'll get on every fire door manufacturer is, assuming the steel door comes with a steel threshold for smoke control, what is the maximum gap width allowed between the frame, threshold, and door leaf?
The easiest way to answer that is to check the test report that the door was tested with as to what kind of gap was underneath it. I suppose to step back then to answer it a different way. Smoke will hit the door at a high level, given that smoke is lighter than air. Generally speaking, the smoke will hit the door, we'd say, from above threshold level. The tests, the EN 1634-3, will have a criteria where the threshold is taped and untaped. So, like in theory, you could have up to 25 mil gap underneath the door, and the smoke wouldn't come through. But in reality and in practice, you're probably looking at somewhere in the region of either having a threshold on the door or else having a drop seal on the door. I know the BS 999 dictates a 3 mil gap underneath the door, but like a 3 mil gap, fixed gap underneath the door isn't really practical because they get off of a biro or a hair clip or anything will stop the door from closing, which will negate the fire rating of the door. I hope that answers it.
And it's probably a related question as well. Does the tag need to be on both the door leaf and frame? This identification tab for the fire door itself.
Yeah, my understanding of it is, and either Mark correct me, please. My understanding is, like we said, the door, for example, the FireBlock door and frame is coming from one manufacturer. They come as a part of a set, so we put it on the frame. I have seen, we'd say, previously going back years ago, we say where a timber frame might be coming from one manufacturer and a timber door leaf might be coming from another, and you'd see both of them tagged. But for steel doors, and particularly, we'd say for under harmonized standards, the door set needs to come from a single source. My understanding is that one tag on the door set is correct.
Yeah, he hit the nail on the head there, really. Like if we were selling the door as a door only, we'd have to put a tag in the door, but as we're selling it as a whole assembly unit, it's only needed in the frame.
Yeah, so that probably leads on to this question then nicely. Can you provide some discussion on oversized door frames used in manufacturing industry hospitals that are not shutters?
Is that oversized door sets as such, like, is it?
Yeah, they give an example of 2 meters high by 4 meter wide.
Yeah, like we'd get asked this question an awful lot. What's the maximum size door you can make? And then we go in.
Mark O'Donoghue smiling there.
There's I suppose.
Oh, I've heard this one before, and you can do it.
The question, like, I suppose, a timber door or a steel door, you're looking at around 25 kilos per meter squared, right? So, like we say, a standard door, personnel door is approximately, say, 30-40 kilos. You'll have a self closer on it because it has to be a self closer if there's a fire rated door. Like, and then we'd say, I suppose we take some of the data center doors where asked for 3 meters by 3 meters. Correct me if I'm wrong, Mark, but didn't you achieve a 90-minute door that'll suffice a 4 meter by 4 meter rope?
Yeah.
Yeah, and like I know the Forster doors as well. They do huge doors, but like 3 meters high. I know the Forster one because we have a Forster door going through at the moment, which is 3.1 meters high, and I think it's possibly 2 meters wide. But at that size of a door, you're going for a power assist door because the person won't be able to push it open, you know?
Yeah,
The weight of the door becomes a huge issue.
It does. Specific in different locations, I'd imagine.
Yeah. And again, look, if for that person who asked that question, email us directly and again, I suppose it's an open-ended question because what size can you make your door? Like, okay, what's the fire rating? What's the functionality? Is there glass in it? Is it latched, unlatched? Is it internal or external? There's a number of different variants that will affect what we can do, you know?
Yeah. Well, that brings us nicely then into the next question, which was asked by the last person, by the way. Same trend going on here. Can you discuss the testing certification approvals for doors that require to have additional metal linings? So they give an example there about high traffic areas in hospitals and for security reasons, etc. Yeah,
there's a standard within either you test them with it, and I presume you're talking about a kick plate or a trolley plate.
I was thinking that too, yeah.
Yeah. So I suppose you test them, you can either test them with the kick plate and trolley plate, and if you do, there's a standard within, or there's a criteria within the standard for the EN 1634 that would allow you to put a 750 mil trolley plate at one side of the door and a 200 mil kick plate at the other side of the door. So again, like, and going back to what Mark and I have said, like the standard is very, very, very comprehensive. And covers that, like, or as I say, 750 one side, 200 mil other side, unless you have test evidence to the contrary, to the duration required.
I presume that's the discussion as well had earlier on in the design stage when you're front ending
correct. Yeah, correct.
proposals. Interesting question here, as always. It comes up in relation to security and fastenings. Are the tested fire doors limit the types of locks that are allowed to be used? Is that a question you find coming up to you?
Yeah, no, always. And I guess that again, we say, I suppose our industry is nearly there's a watermark of pre-Grenfell and post-Grenfell. It has, we say, pre-Grenfell, it was very are much easier, I suppose, to get an assessment on a lock. Post-Grenfell is much more difficult. But I suppose where we come across it now, we say either a test, which is where it's going in time. I'd say over the next maybe 5, 6, maybe 10 years, unless you have the door specifically tested with the lock, you won't be allowed to test to use it. However, at present, if the door has been tested to the standard in a hollow metal steel door or in a glazed door for the duration required, and as the duration or in excess of the duration required, you are allowed to use it. So, like for example, we had a lock there recently, an EFF 351 lock, where it was at a data center. They wanted delayed egress on the door. We had an Abloy EL 560 in the door. They wanted to add this EFF lock. There was no evidence to support the EFF lock for use in a hollow metal door. Therefore, we couldn't use it. So your option there then is either do a full scale EN 1634-1 test, or do an indicative test, which is an EN 1634-2 test, which is a small scales test, for example, and Mark Doyle about a meter by a meter door.
Yeah, something small scale like that. Indeed, it would be perfect for that. Like,
yeah.
Once you have a door tested with a lock, most of them locks are single points anyway. So once you have a door tested with a single point lock, if you do an indicative test with any other style lock, you should be covered.
Yeah.
So there is some schemes that allows for the interchangeability of those components.
Yes, there is. There's a certifier screen, a certifier document. The assessment and the certifier is to BS and to EM 1634. And Mark, I don't know. I do believe the certifier is being phased out to somewhat, though. I think, isn't it?
Well, yeah. There's a complication there because certifier is a part division of Warrant and Fire. So
yes.
There's a conflict of interest there between Warrant and Fire. But all of the test labs kind of have a certifier division or certification division.
Yeah, and it even be called
there's a query in the EU and to separate those two because of their issue of commercial liability.
So I suppose an answer to your question, Sinead, yes, there is, but it varies which region you're in. The certifier was very much came from the BS side of things, whereas I suppose now we're very much in the EN side of things.
Well,
the other Effectus won't even touch certifier sorts. So certifier sorts
and Effectus being the French.
This all comes down to a geographical thing. It's location, and I'm not doing a TV program here for you, but it is down to that. With all of the labs, basically, you have your accreditation, you have your test standards, so your EN standards or whatever it is, or BS standard, like even the old BS 467, the British are finally phasing it out. The Brits leaving Europe has caused a lot of issues in the industry, and especially for Ireland, in the onus that Ireland were generally always aligned with Britain, especially in building control, because for whatever reason it was, you can go back historical or whatever it was, there's a lot of it down to do with geographical and weather. Stuff works in European countries that won't work in Britain or Ireland. So we've always aligned ourselves with the British standards. In fact, our Plan B document is pretty much a copy and paste of theirs, except for a few fundamental words. So with Britain leaving the EU is made that relationship was really complicated now, because we've always aligned ourselves to what the British do. But we're now in Europe on our own, and we have to go with EN standards now. So then labs in Europe won't look at British lab documents. So you have a lot of to and fro, and this is geopolitical nearly in a way. You nearly be as well off now to go to Dubai and test in Dubai all the time, because they're covered for every jurisdiction. Australia, Canada, America, Europe, everywhere. Yeah. But it is really down. Like, I mean, most of the European labs now will just dismiss Warrington's data.
And they dismiss each other's data as well because
They
it's a
do.
personal thing. Like, do you know, like
They do. You kind of you make your bed with one person or another, and you try and hope that they don't make a fool of themselves commercially.
Second last question here for you lads, and I funny feeling this is for Mark O'Donoghue. What's the largest IFD that can be fitted onto the doors, say up to 240 minutes?
IFD.
What's
I,
IFT?
I don't know.
I'm going to cut in here. I think that is it Mark McDade, or he's Australia, I think. As
Yeah.
far as I'm aware, an IFD is a louver in Europe. We call it a louver.
Okay.
I could be wrong now, but that's what I think it is.
Okay, if it is a louver, we have and if you don't mind, Mark, I don't know why I take this one because we do the fire.
You can work away with
Yeah,
it.
we have an FBLS, which is a fire-rated louver system tested with the doors up to 240 minutes, and the largest louver within that family is a 457 by 1524 millimeter louver with a 40% free area. So you get about, I think I worked out today for someone actually. I think it's a 0.278 free area through the door, through the louver within the door.
Okay. Last question for myself, to both of you. What's the future hold for your company? What's it looking like?
If you don't mind, Mark, I go. Yeah, we're very optimistic. I suppose the Irish contractors in general. The recession, if we look back, and it was a dire time, I suppose, in the 2008, 9, 10 up to 2013. However, it did motivate Irish contractors, including ourselves, to get out into Europe. If you go to any of the Enterprise Ireland events within Europe, in Enterprise Ireland being absolutely fantastic, I would have to say, for networking within Europe. Data centers, pharmaceuticals, it's mainly Irish that are in the room. Again, we'd say go to Riyadh or Dubai, mainly Irish in the room for construction. For ourselves in particular, we export probably before we say 2013, we would have exported maybe 10-15%. We're exporting maybe 35-40% per annum at the moment. So, and plus Ireland itself, and again, I suppose it's topical at the moment for FDI. Going back maybe 10-15 years ago, a lot of the pharmaceuticals in particular moved their manufacturing facilities to Europe and back to the States. But a lot of them came back. Janssen in particular there, we'd say in Little Island, I think, moved part of their manufacturing facility out to their mothership back in Belgium, but they couldn't reach the same standards as what the Irish guys could. So the actual product ended up coming back. And like I suppose both Marks are nodding their heads there. They're both used to working in Europe. If you go to Europe, into a pharmaceutical facility in particular, you'll say to yourself, Jesus, we seem to be working to a much higher standard. You'll see a lot of plasterboard, you'll see a lot of ledges on windows, you won't see flush doors, where I think in Ireland we're in a sweet spot in that we're getting the US influence, we're getting European influence, and therefore we have without a doubt the best all-round expertise in both in every level of construction and the products that are sold into construction. So yes, we're very bullish about the future.
And Mark O'Donoghue
From my
himself?
point of view, well, there's two major things that will be of benefit to Forster Profiles and in Forster Profiles Ireland. As soon as the Brits get rid of that 476, the timber door, fire timber door, I say with inverted commas, will struggle. So their industry will really struggle to get where they need to be. Steel should become the more, and steel glaze system should become the more obvious door. We were always outpriced because of in that sector internally for compartmentalization because timber is cheaper. Timber doors are cheaper. So if the Brits get rid of the 476, they're in trouble and we should succeed. The other big thing I'm going to say to you is that I'm not really an internal person. I'm a Façades, which is I've mentioned a few times in the CPD presentation. And if I can change the dial in Ireland and the UK, I'm already working. I work with my colleagues in the UK as well because I'm the only Façade guy in the company in the UK and Ireland. If I can change the dial from 3 or 4% of steel being used in Façades, as in glazing, up to 10 or 15%, we will have huge growth in our industry. But in saying that, the only thing that ever blocked us before, again, was a price issue. Steel was 40% more expensive than aluminium. It's not anymore. I mean, they're on a par. By the time you actually put a steel curtain wall product together versus an aluminium curtain wall product, your installer will have a lot less hassle, more flexibility, quicker speed. The turnaround in building curtain walling in steel is 3 times faster than aluminium. And anybody who's installed them will be able to tell you the same thing. So the I suppose the legacy of us being the most expensive material to use, if people start to really look at it and understand that it's not anymore, then that dial will change, that 10 or 15%. If it does, the growth is huge.
Perfect. Okay. Just want to say thank you very much to all our presenters tonight.
You're more welcome.
Much appreciated. And I'm sorry we couldn't get around to all our questions there this evening, but all the presenters have said if you want to contact the company directly, they'll be able to answer your further questions.